Hi, my name is Mars. When I first started making music, I was very curious about compression. What does it mean to compress the sound? I watched many tutorials, read a bunch of articles, but I didn't find the real answer. Everywhere says that the compressor reduced the dynamic range of the signal, but that didn't make it clear to me why I would need it. And yet, the compressor makes the signal punchy. What does this really mean, though? What would happen if I change any controls on the compressor? Would the signal become less punchy or something? So I decided to show you in this video what happens to the real sound. What happens when you change a certain parameter of the compressor. First, let's look at what dynamic range actually is. Dynamic range is the difference between the quietest and the loudest sound in the signal. Let's listen to the dynamic range of the sample.
1, 2, 3, 4, 5.
You can hear that this example has a big dynamic range, but is this bad or good? In fact, with a big dynamic range, we can show plenty of emotions in the sound. If this sample is playing with a few instruments together, we wouldn't hear all the vocals. You would only hear the last few words.
2, 3, 4, 5. 5.
So the easiest way to avoid this is to reduce the dynamic range of the sample. To do this, I need to compress the signal.
One, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 4, 5.
Let's see what happens to the sample when we compress it. To do this, I will resample it.
1, 2, 3, 4, 5.
We can see the difference in the waveform between the quietest and the loudest word. Here, the dynamic range is smaller. Compressor is the device which compresses the dynamic range. Let's look at the main controls of the compressor. Threshold, level of the sound at which the compressor starts to work. Ratio, the ratio of the compression. Attack, how fast it starts to work. Release, the time of the compression. In this video, I would like to show you what actually happens to the signal. After watching this tutorial, you will definitely understand how to change these controls of the compressor. As I mentioned earlier, threshold determines the level at which compression begins. Gain reduction, the level to which the signal has been compressed. Let's take a look at the example of how much compression has been performed. To do this, I will use the same voice sample. If you change the threshold level to -7 dB, then the compressor will compress part of the word 5. The blue line is the threshold. If you set threshold to -14 dB, compressor will also affect the word 4. You can see here the signal colored black is unaffected. Ratio is the ratio of compression, which determines how much signal will be compressed. Now let's see what happens to the real signal. Here I will use the same voice sample. To see a signal's waveform, I will resample sound for each ratio change. I will use the same compressor settings as before, and I will change the ratio. First is 1:1.
1, 2, 3, 4, 5.
Then 2:1.
1, 2, 3, 4.
Now 4:1.
1, 2, 3, 4.
And then 10:1.
1, 2, 3, 4, 5.
Let's look at the difference between all these sounds. We see that compression affects only the last two words because of threshold level. The words 1, 2 and 3 remained unchanged, and the difference between the values of 4 to 1 and 10 to 1 is not so noticeable. Attack determines how fast the compressor starts to work after reaching a threshold. All the previous examples were with immediate attack. The compressor in this case began to work immediately, and all the peaks above the threshold will be compressed immediately. But in some cases we want to have the attack to maintain the sound's properties. For instance, when we process string instrument sounds. The sound when a violin just starts to play, and you want to highlight this sound. To show you how the attack works, I will make a simple saw wave with volume of -3 dB. I'll compress it with the setup, threshold -18 dB, ratio infinity to 1, attack 0 milliseconds. Such an extreme ratio will make attack effect more visible. Okay, now the resulting volume of compressed saw wave is -18 dB. Let's change the attack to 10 milliseconds. I can hear there is a click in the sound. This is because the signal at the beginning starts to play at the original volume of -3 dB, and then after 10 milliseconds the compressor starts to compress the signal to the level of -18 dB. Now let's check what happens if we change attack to 50 milliseconds. Release determines how long the compressor works after exceeding a threshold level. In other words, release describes how quickly the value of gain reduction is set back to 0. I'll show you how release works on some saw wave impulses. Let's set release to 540 milliseconds and see how it looks on the waveform. You can see that the second impulse's attack is smaller than the first one. It's because the release time is bigger than the difference between the impulses, so compressor doesn't have time to return to its start position. It's very important to choose the right release time. To do this, I suggest always checking the gain reduction level. It should go back to 0 level before the next impulse starts. I'm sure that after this video you will have an idea of what's happening to the signal after compression. Thanks for watching. My name is Alex Mars and this was my tutorial on Compressor Explained. Click like below if you enjoyed this video. See you soon.